Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the IIT JEE exam and NEET exam with a good rank confidently. Now, today in this class, I'll teach you the Newton's third law and free body diagram. Now, what is Newton's third law? We know always from class 10 we have studied, to every action there is an equal and opposite reaction. Based upon the Newton's third law, we draw the free body diagram of any body. Action and reaction always acts on two body. That is, action and reaction does not act on same body. Two body are required to produce action and reaction. So, action equal to reaction and its direction is opposite. When we strike a table as more as a action, then we get more pain as a reaction. So action and reaction is equal but opposite. Now, so this is the third law. To every action there is an equal and opposite. To every action there is always an equal and opposite reaction. Force, that is modern theory. That is, if we explain this third law, then we get this statement. We get this result. Force always occurs in pairs. If body A exerts a force on B, an equal but opposite force is exerted by body B on body A. So now, based upon third law, we can draw the free body diagram when different body are in contact with each other and different body act on. Now let's draw the free body diagram. Free body diagram. What is free body diagram? Suppose stands on a ground. Suppose a man stands on a ground. This is ground. So what is the free body diagram of on the man? Here two system. Man is body A and ground is body B. So the weight free body diagram of the man and ground, if we separate, suppose this is man and this is ground. If we separate, then that is free body diagram means we have to free the body from the other. We have to free the body from the other. Now, if man is free, then what force act on the man? This is the called free body diagram. So here the weight of the body acts. Weight of the body acts in this direction. Now the body exerts a action. A body exerts an action on the ground. So this is R. Then equal and opposite reaction acts on the man. That is called R. So this is action and this is reaction. So free body diagram of the man. Now the man is at rest. That is, man is not accelerating. So equal force will be equal and opposite. So that's why we get R equal to mg, because man has no acceleration. So it is rest. So two force will be equal and opposite. And on the ground a reaction is produced. Now what is the weight of the what is the weight we feel? Weight we feel is the actually reaction. This is that reaction for which we feel the weight. Now when we jump from a high position and is in the free fall, as a free fall, then we don't feel any weight because no reaction act upon us. So we don't feel any weight. A sphere is present here and a wooden plank is raised like this way. Wooden plank. This is a sphere, any solid sphere suppose, and this is a wooden plank is raised upon the sphere. This is the ground. This is the ground. What is the free body diagram of this? Now free body diagram of sphere and plank will be this. What is weight of the body? Acts vertically downward, and the ground, here ground is present here. Free body, ground, plank and the sphere, free body. So what is the free body diagram? And different forces act on these three different bodies. Now here weight of each body acts from the center of gravity of each body. So here weight of the, suppose this is weight of the sphere m1g, m1 plank is m2, so m2g. Now for the sphere and ground there is a action reaction. So if this is action by the sphere on the ground, if this is action by the sphere on the ground, then the reaction acts from this reaction R1. Now here a contact force present. This body and this body touch each other. So here the contact force is always act through the normal. Contact force always act along the normal. Okay, so this is normal line. Normal means normal of the sphere. So this is a so this is another, all forces act through the center. See, this is center, our center. All three forces act through the center. So this is action, and this is reaction. R1. This is reaction. So this is R1. Now here a contact force present. Suppose this is R2. Now this is also for R2. So this is the free body diagram of the body. Here a contact. So at the point of contact there is always equal and opposite force present. So this is R1 and this is action, this is reaction. So important point is that action and reaction does not act on same body. Action and reaction does not act on same body. That is, two different body required to produce action and reaction. Okay, now suppose here two sphere is present and this is a container. Now what is the free body diagram on the free body diagram of each sphere? This is a sphere. Suppose this mass is m1, this mass is m2, and weight of the is m3. Now what is the free body diagram of each body? So if we draw the three bodies separately, then, and this is a small sphere and this is the container. So if you draw the three bodies separately, what is the free body diagram of each body? Now first the weight of each body act through its center. So this is m1g and this is m2g. First this. Now here two point of contact, here this and this 3 point of contact here. So for each point of contact there action comes. So this is action, suppose R1, and this is the action, suppose R2, and this action comes, this is R3. All the three forces passes through the center. This is R2, so this is R2 and this is R3. So here R3 and this is a contact. So if this is R1, R2, R3, R1, R2, R3. Now this is R4. So R4. Now this is R4. Now R3. So here, and weight of the body is this M2G, and weight of the container, suppose M3G. So these are the free body diagram of each body. Free body diagram means if the body keep alone, then what different forces act on the same body. So these are the free body diagram. From each contact point there a action comes. If action comes, then this is reaction. Suppose this is a contact point, so this is action by the container on the sphere. So this is reaction on the container by the sphere. Now this also by the container, weight of the body, weight of the pen act through the center. This is a, here a contact point is present. So if action on the small sphere by the container, and this is a reaction on the container. So these are the, and weight of the each body act through the center. So these are the free body diagram of this body. Now board question or NEET or JEE main question, if you what comes, suppose this question are very important. Suppose 3 blocks are raised on a ground. 3 blocks are suppose 3 different blocks are placed side by side, and a force is act on the mass m1. Now the question is, what is the contact force between, what is the contact force between m1 m2 m2? This is one question. Second question, and contact force between m2 m3. Or question is that, what is the force exerted on m3 by m2, or what is the force exerted on m2 by m1? Same question. The question is, what is the contact force between m1 m2 the contact force, and m2 m3 contact force. You have to find out. To solve this question, first we draw the free body diagram. So first we draw the free body diagram. Now this is m1 and this force is F. So here a contact force. Suppose body mass m1 acts, push the body mass m2 by force r1. Suppose body of mass m1 body push the body of mass m2 by force r1. So this is action and this is reaction. So this is action, this is reaction. Now m2 acts, m2 push the m3 by the force r2. So this is action. So this is reaction. So action and reaction always acts in opposite direction. So first, suppose the force is act here. So m1 push the m2 in this way. So this is the r1 is the force exerted on m2 by m1. So first write r1, then r1 is action, then reaction comes opposite direction. So this is r1, and suppose m2 also push m3 by force r2. So this is action and this is reaction. So here in this way you draw the figure. Now the whole three body moves with same acceleration. Whole three bodies moves with same acceleration, because they are in contact with each other, so they moves with same acceleration. So acceleration, same acceleration. Now what is the equation of motion? Equation of motion is that force equal to ma, Newton's second law. Here different force, this is single force. So if different force act, then we have to take resultant force, Fr equal to ma. So if two or more force act, then we have to take the resultant force. So here resultant force is F in this direction, R1 in this direction. So resultant force will be F minus R1. Obviously this is F in this direction, R1 in this direction. So two force will be opposite. So the resultant will be different. Okay. So this equal to m1a right here. Now for the here R1 in this direction R2. So R1 minus R2 equal to m2a, and here only force R2 present, so R2 equal to m3a. Now add. So if we add, then cancel. Okay. So F equal to, what we get, the result is F equal to m1 plus m2 plus m3 into a. Now that is a equal to F by this. So we get first acceleration. Now we get first action. Now what is the question? Question is that the contact force between M1 M2. Contact force between M1 M2 means we take R1. So from this result, from 1 we get R1. So from 1, so we have to find the R1. So R1 from 1, R1 equal to F minus M1 A, which is equal to F minus M1 into A. A means this. So this is the result. Okay. Now contact force between M2 and M3, R2. So what is R2? From 3 we get R3, R2 equal to M3 into A equal to this. So this is the result. Now suppose 6 blocks are present. 1, 2, 3, 4, 5, 6. Suppose 6 same identical blocks are present, mass M, and a force acts in this direction F1 and this direction, from this direction a force F2 acts. So 6 identical blocks are placed side by side. Now what is the ratio of the contact force between second block and third block to the third block and fourth block? That is this contact force to this contact force. You have to find this question. So for this question, first if we draw the free body diagram, then this will be more longer process. So what is R1 here? So from this total mass is 4m. 1, 2, 3, 4. Total mass is 4m. So this force R1, moves the 4 block with acceleration a. So R1 will be 4m into a. We don't have to calculate also acceleration R1. Now if we draw it here, now R2 moves the 2 block with acceleration a. So here we can write R2 equal to 2ma. Now we can find R1 by R2. So R1 by R2 equal to this cancel, that is 2:1 or 2. This is the process. So as 50 or 100 blocks are present, and if you calculate the contact force between any 2 blocks, then we apply this process. So I repeat once, if we have to calculate the R1, then the right side of this part moves with the force, moves by the force R1. Right side of the part, that is 4m moves with by the force R1. So we can write force equal to ma. Now for R2, now by the force R2, these 2 blocks move with acceleration a. So we can write R2 equal to 2ma. So that's why we can find the ratio. Now if a continuous distributed block, suppose this is a longer blocks, mass m and whole length is l. Now 2 force acts from opposite end, F1 F2. Now find the contact force at a distance y from the end at which F2 act, that is from this end at a distance y. Find the contact force at this section. Find at section y distance. Suppose this end is a, this end is b. Y distance from end b. So this is the question. Question is that find contact force at a distance y from the end of b. So to find that, we have to draw the free body diagram. This. So separate this and this. First separate the 2 part. Now what is the length of this part? The length of this part will be L minus y, and this length is y. So what is the mass? Now to calculate the mass, we have to take mass per unit length. M by L is the mass per unit length. So here what is the mass? This is mass per unit length. Mass per unit length. So if the length is this, for unit length mass is this, for this length mass is this into M by L. Now this also this. So this is mass and this is mass. M1 mass of this and M2 mass of this. Now what is the free body diagram of this? Here force is F1 and this is the action, so this is reaction, and here force is F2. So this is the free body diagram. Now this is a single body moves with acceleration a. So what is the force? Resultant force F1 minus r equal to M1 a, and here r minus F2 equal to M2a. Now if we add, then r cancel, so F1 minus F2 equal to M1 plus M2 into a. Now what is M1 plus M2? M1 plus M2 equal to M, total mass, so a equal to F1 minus F2 by this. This is the acceleration of the body, whole body. Now we have to find the r, actually r. We have to find the r. So what is r? What is r? R equal to M2 into a. M2 is this into a is this. So cancel so this is the answer. So r equal to from on we get r equal to F1 minus M1a. What is a? A equal to this. M1 equal to this, L minus y into M by L. So cancel from this, so we get this result. Now this is F1 minus 1 minus y by L into F1 minus F2. So we can write F1 into 1 minus this y by L plus y by L, F1 1 minus y by L. Now this is the this is the result of the reaction. Here we take F2 and F1. F2 is greater than F1, so the acceleration of the body is this, in this direction. F2 greater than F1. Now if we draw the reaction versus y is taken from this position, from this end. Now if we draw that is reaction versus y, that is reaction varies as we moves in this direction, So if we draw reaction y axis and y along x axis, then when y equal to 0, from this we get, if y equal to 0, this is 0, that is F2. So when y equal to 0, reaction is F2. So this is F2, and when we proceed here, when y equal to L, then this is 0, that is F1. Now F2 greater than F1, so F1 if this length is L. So this is the diagram. Reaction versus y. If we draw reaction versus y, then this will be the diagram. So y equal to 0, force is F2 and force is F1. So this is F1, this is F2. So this is the diagram. And reaction also r equal to, from this we get F1 y equal to 0. This is F1 minus F1 plus F2, that is F2. F1 minus F2 plus F1 minus F2 into y by L. This also a plus bx. So r equal to y plus bx is the graph, is a straight line. The graph will be straight line. Slope is m. f2 greater than f1, we take this is minus a minus bx, so the negative slope. So this is the diagram, this is the diagram r versus y. If you draw the r versus y, this is the linear graph, because y equal to mx plus c graph is linear straight line. And if y equal to 0, then we from this we get, if put y equal to 0 at here, put y equal to 0 at here, we get f2 y equal to 0, then we get r equal to, if y equal to 0 we get r equal to f2, so r equal to f2. And if y equal to l, we get y equal to l, we get r equal to f1. So this is the force diagram, this is the reaction diagram as we moves, as we increase the y. This angle is theta. Suppose a block is present here. Now mass of the block is m. What is the force acting on the block? If this is smooth, what is the acceleration along the acceleration of the block along the inclined plane? Now here the force acts in this direction, weight of the body acts in this direction, vertically downward. Weight of the force act vertically downward, mg. Now here we have to resolve weight along this direction and this direction. Here we have to resolve the weight along this direction, along inclined plane, and the normal to the plane, normal to the plane. We have to resolve the weight along the plane and perpendicular to the plane. So now if this angle is theta, if this angle is theta, this is 90, this is 90, and this angle is 90 minus theta, theta 90, 90 minus theta. Now this angle is 90, so this angle is 90 minus theta, that is this angle is 90. So if this angle is 90 minus theta, then this angle will be 90 minus theta, that is theta. So this angle is theta. Now weight mg, and this angle is theta. So what is the component of this? This will be mg cos theta. We know in vector, if this is a, then the component which makes angle theta with the a is a cos theta. A cos theta. From trigonometry we get, if this is a vector a, then the component which makes an angle theta, with a is will be a cos theta. So this is mg and this is theta, so this will be mg cos theta. So another component will must mg sin theta. Now if the reaction force is at here r, so this is the reaction force. Now as there is no acceleration along this direction, so r must be equal to mg cos theta. As there is no acceleration along this direction, the block accelerates along the inclined plane, this inclined plane, no acceleration along this direction, so r equal to mg cos theta, because if two forces are equal and opposite, then no resultant force along this direction, so no acceleration. So that's why r equal to mg cos theta. And here if the body moves with acceleration a, now this force will responsible for this acceleration. So mg sin theta produces the acceleration of the body ma. So force equal to ma, cancel, so a equal to g sin theta. So for problem, to solve the problem, we have to memorize that acceleration of a inclined plane, acceleration of a body along inclined plane is g sin theta. This is a table, a block is present here and another block is hanging from this pulley. Now this is m1, this is m2. Here we have to find the tension of string and acceleration of two blocks. This is the question. So we have to draw the free body diagram. First m1, we have to draw the free body diagram, m1 and m2. First we have to draw the free body diagram. Now this we have to draw the free body diagram. So separate these two body. Now this weight of this body act vertically downward. This is weight. The body is hanging, so weight act vertically downward. Now if the body moves in this direction, then automatically this body prevents the block to move downward. So prevents means that is M1 exert the force by the rope upward. If this force is T, this is act upward, because M1 try to prevent the motion of the block. So M1 acts the force by the string upward. Now by the pulley this force reverse. So the tension is this direction. This is general concept. If the block move downward, obviously this moves in this direction, so tension act in this direction. So tension in this direction. So if this acceleration is a, now what is the force act on the block? Now here the block weight M1g act here, and reaction also present R, as there is no acceleration along this, so R equal to M1g. So this force cancel this. Now only force present is T, so T equal to M1a, and here two force, this force and this force, so resultant is M2g minus T equal to M2a. The body moves in this direction, so this force will be greater than T, so resultant will be this minus this. Okay, this minus this. So if we add, then what comes? T cancel, so M2g equal to A. So what is A? A equal to, we get this. Now if we put A equal to this, we get T. So T equal to M1 into A. A means M2, and we get T and also acceleration. Different blocks are present here, and a force, a body, a person pulls at an angle theta. This is block M1, M2, M3. Now what is that? Find T1, T2 and whole block, whole acceleration of the whole three blocks. Find acceleration of three blocks and to tension between T1 and T2. Find T1 and T2. Here also we have to draw the free body diagram. Now M1, M2 and M3. So force along this direction. Now whole the three blocks moves along the ground, this direction. So we have to take the force along this direction. That is the component of this force along this direction will accelerate the three blocks, because three blocks are placed on the ground, so the three blocks move along the ground. So we have to take the component of this direction, along this direction. This is F1 cos theta. Now F1 sin theta just balance the reaction, affect the reaction. The F1 sin theta just affect the reaction on the ground. That is, F1 sin theta has no effect the acceleration along this direction. F1 sin theta has no effect on the acceleration along this direction. So F1 cos theta along this. Now the tension T2 here, at which direction? The block moves in this direction, so this block prevents this. So obviously from general concept T2, or if a body, so find the tension at which direction acts. So first, if you if a person present here and observe in front, so in front will be the direction of T2 in front. So here if a man present and he observe M3, then what is the front is here, so here tension is T2. Again here if a person observe this, so this will be the front, so this is the tension T1. And if a person present here and observe this, so this is the front, so this will be the T1. So this direction, to find the tension, just place a man. If a man stand on the block and observe the other, so front side will be the direction of tension. So here he observed the mass M2, so front side this, so this is the tension. And if a person present here and you observe this, so this is the front side. And if a person observe this, so this is the front side. And if a person present here, this is the front side. So that's why we get the direction of tension. Now whole body moves with same acceleration a. So what is equation T1 equal to m1a. Now this equation T2. So body moves in this direction, so obviously right side force will be greater than left side force. T2 minus T1 equal to m2a, and here force F1 cos theta and T2 F1 cos theta minus T2 equal to m3a. So if we add, then this cancel, this is cancel. So what we get, F cos theta equal to m1. So from this we get first acceleration. Now here also find this angle is theta, this is m1, this is m2. Find tension between tension of the string and find acceleration of two blocks given m2 greater than m1. If we draw m1, so we know the m1g sin theta act in this direction, and this is m2. Okay, just draw free body diagram. Now m2g acts in this direction. So if m2g greater than m1g sin theta, then the body moves in this direction with acceleration a. So body moves in this direction, so tension obviously act upward. Now this body moves in this direction, so this body moves in this direction, so the tension here in this direction. If the body moves in this direction, so this is the direction of tension. Now for this motion of the body, equation of motion will be T minus tension act in this direction, wait this, so resultant is T minus this, so T minus m1g sin theta equal to m1a, and this acceleration is this along this direction. For force between T and this, which force will be greater? The force will be greater along the direction of acceleration. The acceleration act in this direction, so this force must be greater in for general concept. So m2g minus T equal to m2a. If we cancel, then we get m2g minus m1g sin theta equal to m1 plus m2 into a. So from this we get a. Now put the value of a here, we get T. So suppose this is 1, so from 1 we get T equal to m1g sin theta plus m1a. What is a? A will be this. If you can write the equation, then you can get easily the acceleration and tension. Just you have to find the two equation. So to write the equation of the motion, then you have to draw the free body diagram. So from free body diagram we get the equation of motion, resultant force equal to mass into acceleration. So first we find acceleration, then we put a in equation 1, we get the tension. Students, this is the end of the class today. The more problems, more theory will be discussed in another videos. To get such type of video and to continue the theory, to continue the laws of motion, the whole chapter, subscribe my channel. Okay, thank you.